All right, can you hear me? I can hear myself, so good. All right, thank you for attending. You're in a framework for comparing account recovery strategies. My name is Dean Sachs. I am a senior security engineer with the AWS Identity team, which is part of Amazon Web Services. I'm also a founding member of ID Pro, and also a SID Pro. If you heard the ID Pro talk this morning, I'm one of the first people to get the SID Pro designation. So what I want to talk about today is, like the title says, account recovery. But I'm not going to talk about specific mechanisms of account recovery other than as exemplars. Rather, I want to talk about how we can compare different kinds of account recovery and assess whether they're appropriate for our environment. But first I want to start with a quote. And the quote is from Jane Eyre. And the quote is, "You are human and fallible." How many of you have made mistakes today? Okay, good. All right, I see a lot of hands. I've probably made mistakes today. In the next 23 or so minutes, you may see me make some more, and I hope you will let me know gently later if you see that. But this quote is exactly why we need account recovery mechanisms. If we don't have account recovery mechanisms, then people make mistakes. They lose their credential, they fail to write down their credential, they break their FIDO hardware key, they lose their OTP, or whatever mechanism it is that they're using, they lose or break them because they're human and they're fallible. And therefore, we need some kind of account recovery mechanism. But this is exacerbated by another human condition. And this other human condition, I have a quote for it, and it's not from quite such a famous person, it's from me. The average human is bad at risk assessment, and really bad at risk assessment. When I think about this, I think about the fact that we take risks each and every day. We get into a car, we get into an elevator, on an airplane. I ride bikes, I go hiking in the backcountry, I carry bear spray. But we don't often think about the risk that we're taking, or we don't know how to assess the risk that we're taking. And so, as I was writing this talk, it took me back to some risk that I took in 2006. So this is 2006 on the Baja Peninsula of Mexico. You can see I'm riding on a four-wheeler or a quad. And my wife and I at the time decided we wanted to take this adventure up the coast, go ride on the beach on the Pacific Ocean because it's beautiful. It would be a lot of fun. Now I know some of you in the audience know me. Some of you know my predilection for hurting myself, breaking elbows, ankles, dislocating elbows, all sorts of things. That's not the risk I'm going to talk about, because I came back from this trip unscathed. However, as we got into a van to head up the coast from our hotel, we met another couple. And they talked to us about their risk mitigation strategy. Specifically, they never travel on an airplane together. And their risk mitigation strategy is because, in their mind, if there was a fatal accident, one would survive and be able to parent their children. Which, not a bad strategy, but is it the right strategy? I can't answer that for them, but what I can do is bring some statistics to the party. So in the time between 2000 and 2019, a 20-year period, there were 12,529 people who lost their lives in commercial airliner accidents. Now, each of these losses is tragic, and we don't want to see this number grow. We would love to drive this number down over time. But when we compare it to the number of people who perish on the roads in Mexico in just 1 year, we see something very different. In 2000, there were approximately 13,600 people in Mexico that died due to roadway accidents. They're roadway fatalities. Now, at the time in Mexico, there was a rate of about 13.9 per 100,000 people who passed away each year due to roadway accidents. Over the next 20 years, up to 2019, the number descended quite drastically to 11.6 per 100,000 people. But due to population growth in Mexico, this means that the actual number of people who perished each year stayed steady. And so what we see is this. In a 20-year period, 12,529 people perished in commercial airliner fatalities, but over 280,000 people perished on the roadways of Mexico during the same time. Now, expand this worldwide, and you see that we get to many orders of magnitude difference between the number of people who perish in commercial airline accidents versus on the roadways. So, why do I share this? I share this because we underestimate risk to ourselves. And we may underestimate risk because we don't understand the risk we're taking, because we're comfortable with certain things like driving. When I'm driving, I'm in control. I think I'm a pretty good driver. I haven't had an accident in 20 years. And now that I said that, of course, that's going to be the next thing that happens. But we underestimate risk, and so because we underestimate risks, we're still bad at risk assessment. And being bad at risk assessment means that we take unnecessary risk. And it's exactly this unnecessary risk that I want to talk about today. So whether it means how you fly, how you drive, whether I carry bear spray in the backcountry or whether I carry an emergency SOS device in the backcountry, or whether I set up an account recovery system for myself for my most important accounts, these are all risks that are misunderstood, and we fail to take the right action sometimes. Sometimes we do the right thing. So if account recovery is really an authentication event, for most cases, the exception being if we're doing identity proofing or re-identity proofing for account recovery. But in most cases, account recovery is a mechanism that uses an alternate authentication mechanism. And that mechanism is a gate. And when we build gates, we need to avoid building gates like this one. Now, this photo was taken in New Orleans. I'm not the photographer. The photographer is referenced on the left of your screen here. However, this gate is representative of what some account recovery systems look like. And even though this is a fully functional gate, we know we can walk around it or easily bypass this gate. So going back to the early 2000s, my wife and I were reasonably newly married, and I was doing taxes, as is my job every year. And I'm doing our taxes, and I need to get some data on stock that my wife held. And this is an American company, and the stock was held by a holding company, a small holding company with a very, very bad website. So I try all the usual passwords. Right? This is 2004, so I don't have a password manager at this point. We got better over the intervening years. But I try all of the usual passwords, and I fail. So I try the account recovery mechanism. And what I see when I go to the account recovery mechanism, it needs two pieces of data. First, username. That's an easy one. Second, mother's maiden name. Now, mother's maiden name, pretty easily well-known piece of information. I know my wife's mother's maiden name, so I enter it, and I'm expected it to be dropped into an account recovery portal where I can reset the password, some out-of-band notification to my wife's email address or via snail mail. That's not what happened. I got dropped into a fully functional session. I can trade stocks, I can buy more stock, I can sell stock, I can get tax documents, I can change the email address, I can change the password. Now, I didn't do anything nefarious. I'm still married to the same woman. And so you know I didn't do anything bad here, but I could have. And that is the point. When we build mechanisms for recovery, those mechanisms should be of equal or probably greater strength than the mechanism that they are protecting, which is the front door for authentication. But if we build a mechanism like this one, as this stock company did, then I'm going to walk around your gate every time. And so for the next couple of years, what did I do? I didn't change the password. I used my mother-in-law's maiden name to log in each and every time. And so we need to fix that. So let's move on and talk about how we can compare account recovery strategies. Now, Erin, in her talk about an hour ago, referenced this, about this iron triangle of account recovery. And you may be familiar with iron triangles if you've ever done something like home repairs or renovations. So in the early days of COVID in 2000, we had already contracted for renovation. It was going to start about 9 months after things really got kicked off with COVID in the United States. And I have a choice between 3 aspects of home repair that I can balance. I can balance on cost, on quality, and on time, or how fast it's done. Now, my choices were to balance on 2 of these. I optimized for time and quality. Because time, thank you for coming into my house and wearing your masks, but I want you out of here as quickly as possible. I want to get done with this project. I also optimized around quality because I intend to spend a number of years in this home. I'm not flipping it and turning it over to someone else rapidly. And so I did so at the expense, no pun intended, of cost. It probably cost more money because of this. And this is the idea of an iron triangle. There are options that you can optimize around, but you can really only get 2 of the 3 and not all 3 at the same time. And so we can do this with account recovery as well. And there are 3 options here, and each vertex of the triangle represents an option. The first is access continuity. Now, access continuity, simply put, means I can gain access or regain access to my account easily without undue delay. The second is security. And I've already kind of referenced this. Is the solution secure? Is it secure to roughly the same degree as the front door, the primary authentication mechanism, or is it subject to unmitigated or unacceptable risk? The third is privacy. Do I have to give up an excessive amount of private information in order to access this account recovery pathway? So for instance, I mentioned identity proofing or reproofing. That obviously is impactful to privacy. But in order to use the triangle, we have to have a way to compare strategies on each of these aspects. And so each vertex, plural vertices, are represented by continua, which is the plural of continuum. And so for each of these vertex, I can create a continuum. And this is what I've done here. And I've chosen 4 different account recovery strategies. Now, these were just the 4 that I chose. You can choose whatever ones you want and map them to this. And I need to make it really clear. The values on this continuum are not real values. They are relative values. Your choices for where to place these on the continuum may be different than mine. So I will caveat all of this with your mileage may vary. The only thing I expect each of you to do if you use this strategy is to be consistent in how you use it and how you rank these things relative to one another. So how you read this continuum is from left to right. Now on the left side, you have no account recovery. And this makes sense in the context of access continuity because the left side represents low access continuity, or in this case with no account recovery, which is a formal option for any account recovery system, though maybe not a good one. That obviously sits low on the access continuity continuum. As we move to the right, we get to stronger and stronger access continuity. So recovery codes, we're all familiar with those, identity proofing. And the fourth one on here is an interesting one. I've called it a cryptographic possession factor. But what I'm really talking about is a FIDO2 hardware key. And I'll come back to why I've chosen this one in just a little bit. If we look at the security continuum, something interesting happens. No account recovery shifts all the way to the right because I've protected the security of the account if I can't abuse the account recovery system to get back into it. Now we can argue about the CIA triad and accessibility and all those things, but in my mind, this is secure for this use case, even if it may not be particularly usable. Recovery codes, on the other hand, have shifted all the way to the left. Now you might be saying, well, Dean, recovery codes aren't insecure, and I agree with you, they're not insecure. However, relative to the other 3 options on this continuum, they are the least secure in my perspective. Moving on to the privacy continuum, we see more changes. Now you see recovery codes have moved up slightly, and identity proofing has moved to the left, to the bottom. And it's moved to the left here because identity proofing is, by its very nature, privacy impacting. So we can take these continua and use it to map to the triangle. And I'm going to take 3 of these. We're going to do no account recovery. We'll talk about recovery codes, and we'll talk about the cryptographic possession factor. So first, let's talk about no account recovery. So as you'll recall, it was high on the continuum on both the privacy and security scales, but very low on the continuum on access continuity. And it looks something like this when we map it out to the triangle. So this becomes a visual representation that you can use to show the relative value of different strategies. And so here what we're showing is that we have a strong balance between security and privacy while we have no access continuity. And again, this may be an appropriate strategy for some environments, but not all. The next one is recovery codes. And as you'll recall, I said that low, relatively speaking, on the security side, moderate to high on the privacy side, and has pretty good access continuity. And where I've mapped it on the triangle is over here. So it aligns along this access continuity to privacy line, showing that we've really decided to balance toward access continuity and privacy. And it may be a bit hard to make out, but I've placed this somewhere below the midpoint or the center of this triangle. And the reason I've placed it below the midpoint of this triangle is because of the simple reason that you are human and fallible. When I get recovery codes, have I saved them? Do I have access to them when I need them? I'm standing on stage right here in Denver. If my recovery codes are in my fireproof safe in my office in Seattle, it doesn't do me a lot of good right now. So that impacts my ability to recover right now. I may be able to recover in a few days. And so this gives you a visual representation of where recovery codes may fall. Now, the cryptographic possession factor is an interesting one. In 2019, along with the FIDO Alliance and some co-authors in the FIDO Alliance, I wrote a paper on account recovery using FIDO2. And specifically what we were talking about is FIDO2 as a second factor. And so FIDO2 hardware keys. You may know them as UB keys, or there are other manufacturers as well. And our conclusion was the idealized account recovery strategy in this world is to have a secondary or a tertiary or an nth hardware key. Because inevitably I'm going to break or lose or do something because I'm human and I'm fallible. And so this FIDO2 key, when we look at it, it has high security, it has high privacy, and access continuity is good, but similar to the recovery codes, I've got to have the thing in order to use it. And if I don't have the key with me, then it can be hard to recover. And so if we think about this in a corporate sense, as an employee, I have multiple security keys that I use to authenticate to services. I have a primary key that stays in my laptop, and I have a secondary key and a tertiary. And some of my friends will know I often share my bucket of keys. I have a huge bucket of hardware keys sitting on my desk. However, if that hardware key is sitting in Seattle and I'm here, I can't use it. So then the challenge is, well, okay, I need to bring a second one with me if I'm traveling, but now how do I keep it separate from the primary key that I'm using every day? Because if I put it in my backpack with my laptop and my laptop bag is stolen, it goes with it. If I put it on my keychain and my keychain is stolen because it's in my laptop bag, same problem. And so we still run into these human problems of how do we get to access continuity and recoverability in an easy to use fashion. And there's no perfect answer here. We have to compromise on some points. So generally I'd like to argue that all credentials are subject to account recovery, and they're all equal in the terms of account recovery. But there are some things that are different. And specifically what I'm talking about here is syncable credentials. Now, you've probably heard a lot about passkey and multi-device credentials this week, but that's not the only kind of a syncable credential. Show of hands in the room. How many of you use a password manager that is synced to the cloud in some way? Most of you. If you're not using a password manager, please do so. It's your best bet to create strong, secure passwords and use them everywhere. But those are syncable credentials as well, because now I have synced those to the cloud. And that means there's another pathway to recover. And it may be that pathway to recover is that they're synced to a different device, or there may be a recovery pathway for 1Password, LastPass, or even credentials within the Apple ecosystem within their built-in password manager. And the same is true for multi-device credentials or passkeys. The same externality exists there. Now, I am not arguing that this externality is bad. In fact, I think this externality is okay for most use cases. However, it is up to you as the identity architect or the security engineer or whatever your role is to add this externality into your threat models, consider how this impacts your customers, and whether syncable credentials are usable in your environment. While we're on the subject of syncable credentials and using them in your environment, if you're using passwords, you don't have any way to know if they're being synced somewhere. You don't know if they're stored in a password manager. And if that is a problem in your environment, then I urge you to use some kind of non-syncable second factor, such as the aforementioned hardware security key. All right, the last thing I want to talk about is nudges. And so in around 2005, there was a book published called Nudge, surprisingly, by Richard Thaler and Cass Sunstein. They're two researchers, psychological researchers, I believe. And they describe nudges as, quote, a nudge is any form of choice architecture that alters people's behaviors in a predictable way without restricting options or significantly changing their economic incentives. The canonical example that they use, and I apologize if you're not American and familiar with how American retirement systems work, but when you go to an employer and you work for an employer, often you're asked to put money into what is known as a 401k, which is a retirement vehicle. And when you start with your employer, often you have to fill out all these forms and say, I want to put this percentage each month or this amount of dollars each year into this 401k. Their example with the 401k is to nudge users into automatically putting money into that 401k. So for example, if you do not take any action, automate putting 3% a year into that person's 401k. You have to opt out of it. And it's done because if you don't have this 401k and you don't have this retirement vehicle, you may find yourself without enough money to retire comfortably at the end of your working career. They also argue that maybe you should add 1% a year to that and do it automatically, because as humans, we're not going to go in each year and update these things because we're human and we're fallible and we don't think about this. And so nudges are clearly important when dealing with account recovery as well. What we want to avoid is what's on the right here. So this image, and it may be hard in the back to see, I found this outside of Schiphol Airport, which is in Amsterdam. I was stuck there overnight a few weeks ago. And was tired, I'm cranky, I have a room in the 3000s block, and I need to go find it. I'm standing outside the elevators. My normal behavior would be just go to the 3rd floor. I saw this and I was like, oh wow, that's a really bad user experience, telling me that the 3000 block of rooms is on the 2nd floor. And so I would have made a mistake, again, being human and fallible, had I not actually looked at this sign. So we want to avoid this experience for our users, and rather we want to nudge our users into the right behavior. And what does that look like? So I recently added multi-factor authentication to a social media service that I use. And when I did so, it was a virtual OTP. When I did so, a couple interesting things happened. First of all, I registered the OTP with my authenticator. Awesome, great. It's a syncable credential. It's synced to the cloud. So, same externality there. But they did something really interesting in that they also handed me 10 recovery codes. And they told me exactly what to do with them. Put them away in a safe place. Have them accessible if you need them and you don't have your virtual authenticator. And oh, by the way, if you lose your authenticator and you lose the recovery codes, sorry, we can't give you your account back. They told me exactly what would happen and what I should do to take the right actions to prevent getting locked out of my account. And these are the kinds of nudges that I would encourage you to include in your own systems when you're thinking about account recovery. And this may also include nudges on maybe an annual basis to say, is this email address that we have for you correct? Is this phone number correct? Or do you still have one of these recovery codes? Can you prove it to me? Because we want users to be able to recover safely and securely and not have to resort to other means that may be less secure. Finally, I wrote this article for account recovery for the ID Pro body of knowledge. It's where a lot of this thinking comes from. So you can read the article at bok.idpro.org. See, there was the mistake. I told you I would make one. So you can read the article there, and it covers the iron triangle and also covers some specific examples of different account recovery mechanisms that one can use and some of the benefits and challenges with each of them. It is ever evolving. There have been updates to the article, and there will be in the future. If you see anything that you don't like in there, you disagree with, I encourage you to put in a pull request at the GitHub repository where these things are managed. Thank you very much for your time. I appreciate it. If you have any questions, I'd love to take them. I can also take them on Twitter or LinkedIn or wherever else you may find me, or really any place around the conference for the rest of the week. So thank you for listening. Any questions? I can, yes. That one? There you go. Yes, sir, you had a question.
So yeah, quick question. So do you typically provide multiple ways of recovery? And if you provide more than one, how do you balance that security and usability?
So the question is, do you typically provide multiple mechanisms for recovery? And if you do, how do you balance security, privacy, access, continuity with each of them? This is an individual choice. So it is an individual choice for your environment, your customers, your specific needs. Yes, there is value to providing multiple different mechanisms. Some customers may prefer one mechanism over another. However, it is up to you as the architect or the security engineer to decide what are the appropriate mechanisms in this environment that I can set up and ensure that your customer has set up at least one of them. So the key, I think, in this scenario is that they should both meet similar levels of access continuity, privacy, and security, even though they're coming through different mechanisms. What we don't want to do is we don't want to, if you remember the slide with the gate, we don't want to create a gate that I can walk around the left, I can walk around the right, I can jump over the top, right? We want to create gates that are functional and actually take effort to walk through so that we can separate the malicious actors from your customer or your user. Thank you. Any other questions? All right. Thank you very much for your time. I think it's time for lunch.
Thank you.
Thank you all.